Hi everyone! We learned how to find function values for angles around the unit circle. But right now we're going to try that in reverse. We will need to find angle based on the given function value. Let's try it. So this is how the question sounds. Find all values of theta if theta is in the interval from 0 degrees to 360 degrees, 0 is included and 360 is not, and has the given function value. So that's the first one. We know that sine of that mystery angle theta is negative radical 3/2. And generally when you're given sine or cosine of the angle, to find answer pretty quick and easy. We just have to remember that sine values of angles around the unit circle are corresponding to the y-coordinates of the points on the terminal sides of those angles. To help us with the search of the points that have this y-coordinate, let's use this negative sign. It will narrow down our search only to two quadrants where sine is negative. Well, once again, if sine corresponds to the y-coordinate, I just have to think in which two quadrants y-coordinates are negative. And they are quadrants 3 and 4. That's where y-coordinates are negative. So what's left to do is to look through the points in those two quadrants and find the two with the y-coordinates negative radical 3/2. So here I can see one, and in quadrant 4, here's another one. And as I can see, the corresponding angles are 240-degree angle and 300, and that will be my answers. So I'll just make a few notes. So this negative sign helped me to narrow down my search to only quadrants 3 and 4. And as I looked at those two quadrants, I found that angle theta can be either 240 degrees or 300. And once again, when you're given sine or cosine of an angle, so your job is to find the given value within the coordinates around the unit circle. Let's try an example where we're given secant of an angle. And as we know, secant values are not labeled around the unit circle. Our approach will be to use the reference angle. An idea behind it is the following. We know that our angle theta or angles theta will have same numerical part of their secant value as the reference angle. In other words, secant of the reference angle theta prime is also radical 2, and it's always positive. As you remember, reference angles are always acute, between 0 and 90 degrees, so you can think about them as angles from the first quadrant. All their function values are always positive. I know that secant of theta prime is radical 2. But what is theta prime itself? For that, I'm going to use the table of trigonometric function values. Here is secant, and in this row I have values of the secant function for various angles. And here I find radical 2. So I can see that radical 2 is the secant value of the 45-degree angle. That means that theta prime, the reference angle, equals 45 degrees. As I return to the unit circle, this information about the reference angle narrows down my search only to angles that are related to 45 degrees. Angles like 45, 135, 225, 315. But there is still one piece of information that I haven't used. And that is the fact that the secant value for my angle or angles is negative. That means that I only need to focus on the quadrants in which secant is negative. So we know that secant is reciprocal of cosine, and cosine corresponds to x. And x values are negative in quadrant 2 and 3. So both secant and cosine are negative in those two quadrants. And that finishes my search. In quadrants 2 and 3, two angles that have the reference angle of 45 degrees are 135 and 225. So theta equals 135 or 225. So to summarize the process, I basically had to take two steps. First, I identified the reference angle using the table and the fact that its secant value has the same numerical part as my angle. And in step 2, I used the fact that the given secant value is negative, so that narrowed down my search to quadrants 2 and 3. As I put those two together, I got the result. By the way, it doesn't matter in which order you do those steps. You can start by identifying the correct quadrants and then work with the reference angle. And here's our last example. The steps will be similar as with the previous example. We need to find all values of theta if we know that tangent of theta is radical 3/3. Just to demonstrate that there is no difference in which order you perform steps, this time let's start by identifying the correct quadrants. So in which two quadrants tangent is positive? Well, tangent is y/x. It's going to be positive in the quadrants where both x and y coordinates have same signs. So that must be either quadrant 1, where both x and y are positive, or quadrant 3, where both x and y are negative, and then when you put them in the ratio, they produce positive result. Okay, so we're only looking at those two quadrants. Next, let's determine the reference angle theta prime. So we know that tangent of theta prime will have same numerical part, but only positive. Well, in this case, it's going to be exactly the same. So it's going to be radical 3/3. As I look at the table of values, here's the tangent row. In that row, I need to find radical 3/3. Here it is. And that corresponds to 30 degrees. That means that theta prime, the reference angle, measures 30 degrees. Now, as I return to the unit circle, what I'll do, I'll sketch two 30-degree reference angles in quadrant 1 and quadrant 3. And that will help me to identify angles theta that I'm looking for. So in quadrant 1, the reference angle theta prime is this one. Remember, it always has the x-axis as one of the sides. And in quadrant 3, the reference angle that measures 30 degrees is this one. Theta prime equals 30 degrees. And that means that the two angles that I'm looking for, angles theta with the provided description, are 30-degree angle in quadrant 1 and then 210-degree angle in quadrant 3. That will be my answer. Theta equals 30 degrees or 210 degrees. So these are the steps for finding the unknown angle given its function value.